Hello everyone, welcome to the another session of this home lab chemistry experiment. In this experiment we will talk about the melting point temperature technique. What is the melting point temperature technique and why we use in organic chemistry experiments, and then we will talk about some more detail. So basically this is a thermodynamic property of or compound, or basically it's a thermodynamic process of an organic compound, where if we have a solid phase compound and when we heat this compound, slowly it get more kinetic energy and it start melting, and it goes from solid phase to liquid phase. And once we cool this liquid phase, and it come back to the solid phase. So basically this is like a equilibrium process. And so let's talk about something more about what is the melting point and why we use in organic chemistry experiments, and how we report this melting point temperature of an organic compounds. Usually we report in the range, and so why we need to report in the range. Next is what is the eutectic point, and how the pure substance or pure compound melt versus impure compound. So what is the difference between the pure compound melting point and the impure melting compound melting point. So let's talk about some more detail, then we will. So the melting point, what is the melting point of a compound? Melting point is a technique used to identify the compound and to check the purity of compound through the melting temperature. So we use a melting temperature to find out the purity of a compound, and also we identify the compound if this compound is what is we want, so required one. Further in detail, the melting point temperature of a compound is the temperature at which changes from a solid phase to liquid phase. So compound changes from solid phase to liquid phase whenever we add the temperature. Next is the further the melting point is related to the amount of kinetic energy we give that one add to the solid substance to overcome the intermolecular attraction, so that maintain its solid state under given conditions. So for an example, if we have two molecules of the solid and they have some intermolecular attraction between each other, so they like each other, so solid, and this is the intermolecular force or intermolecular attraction. So when we give the temperature, so their kinetic energy increases. So once the kinetic energy increases, their intermolecular force break it down, and these two molecules goes into without intermolecular forces, and then they become liquid. And next is why we have to report the melting point temperature in a range. Usually we report the temperature in the range because it is very difficult to find the exact melting point, because it is a thermodynamic process. So what is the meaning of thermodynamic process? When a substance begins to melt in a dynamic equilibrium between the solid and liquid state exit. So solid, as we have seen in the board, and liquid, so it's a dynamic equilibrium. Whenever we give the temperature, it becomes liquid, and when we cool it, it becomes solid. So because the energy transfer to this system is not used entirely at once to convert all the solid into liquid phases, this is the reason the range comes for the melting point. Therefore, a single temperature value is commonly not reported, but rather the temperature ranges. So usually report 2 to 3 degrees Celsius in the range. So like 101 to 105 or 104 degrees Celsius. This is the range of, for an example. Next is what is the eutectic point and eutectic mixture. So suppose you have a pure compound A and pure compound B, but you are taking a mixture of these one. So if you have taken mixture of A plus B, right? So eutectic point is an equilibrium point of temperature at which the mixture of the two pure compounds melt at the constant ratio, and this mixture is called eutectic mixture, and this temperature will be called eutectic point. So this is also called E point. So for an example, if we have pure A and pure B, and we have different composition like a 10% of A, 20% of A, and here is 30% of A and 70% B, for an example. So in that condition, this will be a mixture. This is called eutectic mixture, and at this composition the compound will melt with the constant ratio of both pure compounds. Next is the pure versus impure sample of melting point. Melting point is a quick method to determine if a sample is pure or not. And impure sample display a decrease in melting point. This is very important. If you have impure compound, basically they display decrease in melting point than pure one, and melting point range is much larger. So probably it will be more than 2 to 3 degrees Celsius range. And the reason for this is due to the entropy gain. So whenever we give the heat, all the molecules become random, more disorder happen. So disorder means, and if you remember that nature loves the disorder. So on going from solid state to liquid state, this is the reason when we give the temperature, entropy gain for the compound, and that is why its range increases. So are we ready to start our experiment? Let's review first. The material is required here. I need one pan, and then a couple of bowls, some water, and then I bought these thermometer. This is the infrared thermometer, and have the minus 23 degrees Celsius to 550 degrees Celsius it can measure. And when I bought this one, it came these two together, so probably I am going to use these two together. And this thermometer have the capacity minus 50 to plus 300 degrees Celsius measurement. So I have given the link of these two thermometer in my video. You can see in the description, and if you want to buy, you can use it. And here I'm taking a scale, might be we need this one. And then what are the material we are going to test for the melting point. So in our home, you can see we will compare the dark chocolate. So this is the dark chocolate. This is the 85% cocoa, which is this is the most darkest I find in my grocery store. And then we have the milk chocolate, so extra creamy milk chocolate. So we'll compare the melting point of these two. And second, we have here unsalted butter. Unsalted means there is no salt, but this is the salted butter. So we'll see if there is any difference in the melting point of these two. And then third one, you can take also, this is the wax, candle wax. And then versus crayons. So crayons have the colors and all, so you can see different type of colors. So we can take this one. And the fourth one, you can take also if you have a different type of cheese in your home. So far I have these three items in my home, so we'll test this one. And then you need some pen and pencil and paper. And then before that, everything to start, wear goggles. Eye safety is important. Or if you have this goggle, you can use it. And so let's start. Okay, so in this experiment there will be a heat and fire hazard, so you have to be careful whenever you touch any hot thing. And before that start, we have to do calibration of our thermometer. We want to know if our thermometer is working or not. So I have taken here tap water. So let's start the tap water first, and here you can see it says 23 degrees Celsius. So this one is showing 23 degrees Celsius, note down, which is nice. And how about this one? So this is showing 25 degrees, 24. Maybe I will leave it just 1 minute and then we'll measure. Let's measure this for the ice. So here you can see I have ice in this glass. So what is the temperature of ice? And this is showing minus 1.1 degrees Celsius. So look like this is very accurate. Minus 1.1 degrees Celsius. And let's see what this is showing, 24.3 degrees Celsius. So slight difference in the thermometer, 24.2 degrees Celsius. Now I will keep this into ice and then we'll see what it is reading. So we'll come back after some time. It's moving very fast, but it will take some time. It's not like a laser thermometer. And then third one I have here, you can see this water is boiling right now. Let's make more. So I have the boiling temperature water. So let's see what it is right now. Okay, right now 83 degrees Celsius. Let's start the water boil a little bit more. So 84 it's going to be, I'm going to heat more. And let's see meanwhile this one. So what it is measuring right now. So it's still going down 2.4 degrees Celsius. So this thermometer is comparatively slow. It will give just like in your lab, thermometer moving slowly. So this is the same thing. It's mimicking like exactly same. And it's very close, 1.5 degrees Celsius. So let's check this once again. So it's 90 degrees Celsius. So it's look like they are working very nicely. Thermometer, it's increasing. So boiling water is, net makes full. Basically it is nearly 100 degrees Celsius, which is nice. 97, 98. Okay, so it's very close to 100 degrees Celsius water. So probably 98 it is showing, boiling water it is showing 98 degrees Celsius. So 98 degrees Celsius, and this came at 1.0 degrees Celsius. So 1.0 degrees Celsius. And then now I will move this to boiling water. Let's see what it is reading. So it's moving basically 23, 44, oops, 58, 60. So this thermometer is moving slowly. So this is the difference. If you have different type of thermometer, you have measurement will be slow comparatively with each other. So this is also going towards 90 or 80, and now this is showing 101 degrees Celsius. So 104 degrees Celsius. Yeah, so probably I will say still. And this boiling water is showing, it's also slowly moving. Okay, so I will write somewhere boiling water it is showing probably 93 or 95 degrees Celsius. So this is the, you can see this is the difference. You have to calibrate your I'm going to write here like 95 degrees Celsius. So my second thermometer is showing 95 degrees Celsius. So this thermometer is moving slow, therefore I'm going to use my laser thermometer, but probably this can give us the temperature of the water bath. Okay, so now oops, let's close this heating and then we'll start the experiment. Okay, now so let's start melting point for the first dark chocolate, which is this piece. I'm just taking to measure how much gram I'm taking. So this is around 40 gram, and in this chocolate, this is the milk chocolate. This is also 40 grams. So probably I will use the same amount in both of them. So this is the 40 gram dark chocolate, and this will go in this bowl, and dark chocolate is here. So let's add some cold water first. I mean room temperature water, not cold. And here our temperature will show wake up. So this is showing around 24.8 degrees Celsius, which is nice. Now I start the stove and then place it this. So we cannot heat the anything direct. I have to make the water bath. So this is my water bath, and then I'm going to this thermometer from outside. So first click on, and then we'll place here on the side. Hopefully it should fine. Okay, to check the it will give us approximate temperature, but meanwhile we will in between we will keep measuring the temperature of our chocolate. So what you have to do, you have to put the laser directly on the chocolate. Right now 29 degrees Celsius, and here is 33 degrees Celsius in this one, and you can see it start melting. So probably 30, you can see 35, 34, and here we have 38. So you can see dark chocolate start melting already. Be careful, don't put the laser on your eyes. So I think it start melting from 34 degrees Celsius, and right now 44. So here you can see 48, 50 degrees Celsius water, and my chocolate is dark chocolate is already melting. So what is the temperature right now? It's a 60. So it start melting around 34 degrees Celsius. So I will write down. Probably it start from 34 degrees Celsius, and see how much time it will take. And time actually within a minute it start melting. So 40 gram chocolate, dark chocolate, melt (65 degrees Celsius) right now. Actually there is a two temperature, so I'm just trying to take a temperature of the liquid. Here you can see measure 63, and what is the here 69, 70 degrees Celsius right now water. It is showing 68 something. So probably it is melted already. Now I have to close this, and so I will write somewhere it start from 34 degrees Celsius, and probably maximum 55 to 60 degrees Celsius, it start melting very nicely. Next I have to remove this chocolate from here and then throw this water, put it in the room temperature water once again. So now we will start the next with the milk chocolate. So I said you that this is the amount, same amount, around 40 milligram, 40 gram, and place it into bowl. Now fresh bowl and add cold water, means room temperature water, not cold. Then we'll place our chocolate and start heating. Make sure heating would be even, so just normal. And then we'll measure right now what is the temperature of chocolate. So how come it is 40? Actually we have to check the water temperature. It should not be too fast. Probably it was a little hard, so we'll replace the water once again. So I have to cool down my pan. It was very hot, so I let it cool, and then now I'm going to start my next experiment. So you can see fresh water, cold water again, room temperature water again, and check the temperature first of this water before starting. So right now it's 24.4 degrees Celsius, which is nice. Now I will place this chocolate, milk chocolate. So this is the milk chocolate. Now we'll find out, and then start stove. So we'll keep measuring the temperature, at what temperature it will melt. So we start at 343 and see temperature changes very fast here. So right now 28 degrees Celsius. We have to keep looking on the side of this chocolate to see. Let me turn on the light. Okay, so we can see much nicer. 29, 31. Chocolate temperature is increasing. 31 degrees Celsius, 32 degrees Celsius, 35 degrees Celsius, and probably 31 right now. It's around 30. So here you can see it's 43, 44, 1 minute almost, and then 35, 33, 39, and I'm not seeing anything from the side. Actually it start melting. You can see it start melting if I will touch it. So here you can see it start melting also. So what is temperature? 40. So this chocolate is start melting around 40 degrees Celsius. So this is the difference between the dark chocolate and so I will write down it start melting around 40 degrees Celsius. 40 degrees Celsius it start melting. Let's see how much time it will take to melt more or completely. And comparatively, if you will see, it is melting completely slower than my previous one. It's around 47 degrees Celsius. So whenever we do melting point measurement, you have to be very patient, keep monitoring the temperature. Very slow melting of this chocolate. Here you can see it's not like dark chocolate. Dark chocolate melt very quick compared to here. Slow melting. Let's see what is the temperature now. 55, 50 degrees Celsius, 53, 49, 50. This is the, I like this thermometer. Very handy, very easy, very quickly you can measure compared to that stick one, long one that was taking very long time. So here you can see this chocolate is melting comparatively slow, and so this chocolate is melting very slow, as well as at high temperature. You can see it's still 50 degrees Celsius and it's not melting. So this is extra creamy chocolate. I will show you when it will melt and what temperature. Now 349 and chocolate temperature is 78-80 degrees Celsius. But I notice one thing, that if I'm going to touch here, it's all liquid right now, but it's not semi-solid. You can see, I mean, it maintained the texture, but it did not melt as the previous one, the dark chocolate. So I'm going to close this thermometer stove, and probably it melt 76 degrees Celsius right now. 80. Okay, so this was the second experiment. We'll note down. So probably it start from 60 and then it melted somewhere 60 to 70 degrees Celsius, and it maintained very texture. So now we are done with the chocolate experiment. So next experiment we will do with the butter. So this is the salted butter, this is the unsalted butter. So I'm going to take each 1 tablespoon, and then we'll do one by one. So first I'm taking unsalted butter. This is the unsalted butter. You need a knife also to cut it. So this is the 1 tablespoon butter. This, and let's see how much gram it is have. So this will be around 70 gram. Okay, actually it is already melting in my hand. So here we have unsalted butter. Next, cold pan, then water. Every time we have to start from the room temperature water. So water temperature is, you can see, 21. Probably it was 22 degrees Celsius. Now let's keep the butter inside and then put it down. And then we'll see what temperature it start melting. Right now temperature of butter is it came from the fridge, that is why it's cold right now, 20 degrees Celsius. Now its temperature is increasing, so I will show you what temperature it start melting. Actually you can see melting, it start melting very quickly. So right now 42. I think I missed the temperature. little bit. So probably it start melting as I notice around 40 degrees Celsius. Basically no, it start melting around, yeah, even smaller. Actually water temperature you can see right now 60 degrees Celsius, so around I think it start melting around 30 degrees Celsius. It start melting very quickly. So now I'm closing it and writing here start from 30 degrees Celsius. 30 degrees Celsius. Now this is the salted butter. So let's take 1 tablespoon of this one also and see how much gram I have here. I use with the paper last time, so I'm going to use the same thing. So it's around 81 gram, and place it into here, and then fresh water, room temperature water. Check the temperature of water is 23 point. Now we place and start stove. Now check temperature of butter. Right now 26 degrees Celsius. Actually it is saying 25 degrees Celsius. However, it also came from the fridge, and water 32 right now. It's increasing 28 actually. It's rapidly changing. So we'll see what temperature it start melting. So now you can see within a minute, if you see from the side and the bottom, it start melting, and temperature is 33. 35. Water temperature is right now 45, and here, so this start melting around 33 degrees Celsius. Little higher temperature, but it start melting very quickly also, this one. 40, 44, 47. Yeah, right now it's very high. So it start melting 33. Okay, so now you have seen that I performed 4 experiments on the melting point. One is with the dark chocolate, second is with the milk chocolate, and then unsalted butter, and then salted butter, and these are my data and results. And wax and crayons I'm not doing right now, but otherwise this video is going to be very long. So you can perform this experiment with any of these material, or you can select your own material in your home, and then report your data and analysis and conclusion. So I hope you will learn from this experiment a lot about the melting point, and you can perform at experiments. So I will give you a summary about my conclusion. So here the summary of my conclusion is experiment is this. So first make sure that there is a heat and fire hazard, so be careful, and you have to do calibration of your thermometer, whatever the thermometer you are using, and use these two, but mostly I use this eye laser sensor thermometer. So I calibrate them to check the water temperature at 23 degrees Celsius, ice temperature was measuring -1, which was correct, and boiling water temperature was 98 degrees Celsius. And then we tested the melting point of the dark chocolate. So you can see dark chocolate is still, it's all messed now, but some portion is still hard. And here milk chocolate have very thick texture. It's very slow melting, and these are the melting point temperature. And before running next experiment, you have to cool your pan and start from the room temperature. Start always from the room temperature water. So this is the dark chocolate, 34 degrees Celsius to 55 degrees Celsius, and 40 gram I use. And here is 40 degrees Celsius and 60 to 70 degrees Celsius. So this was the difference. Probably milk chocolate have more contamination, that is why it's melted very slow. And unsalted butter was very quick. It was even melting on my hand. So it start melting around 30 degrees Celsius to 33 degrees Celsius. And salted butter, it was very close, melting to 33 degrees Celsius to 35 degrees Celsius. So this was the conclusion, and enjoy your experiment by your doing. And last but not least, I want to show you some of my plants which I am trying to grow in the water. So here you can see how beautiful roots are. And these are the fenugreek leaves, fenugreek plants. They are in the 5 glasses. I'm just changing water every day, and they are growing very nice roots here. Isn't it cool? Thanks for watching.